corrosion equipment, that is, in order to monitor the corrosion, electrochemical techniques can be used, because the electrochemical techniques are vital tools for evaluating the corrosion behavior of a metal, passivity and electrochemical properties of materials. So the technique include electrochemical impedance spectroscopic studies, that is, you can measure you can plot Nyquist and Bode plots, and potential dynamic polarization studies. These methods provide insight into charge transfer resistance, corrosion rate and electrochemical behavior of coatings, oxides and biomaterials. So, in order to perform the electrochemical impedance spectroscopy and potential dynamic polarization studies, Autolab PGStat 302N is used. So, Autolab PGStat 302N is a modular, high precision potentiostat galvanostat designed for advanced electrochemical applications in research and quality control. The overview of Autolab PGStat 302N, the manufacturer of this PGStat 302N is Metron Autolab PV, the Netherlands. The type of equipment we have used is potentiostat galvanostat with the optional frequency response analyzer, and modular design, that is expandable with modules like EIS, EQCM and bipotentiostat. The software used is Nova software, because it is user friendly and script based. The specification for the PGStat 302N, the voltage range is plus or minus 10 volt, current range plus or minus 250 milliamps. Even you can extend the current range. Then potential range is less than 10 microvolt, and frequency range for EAS is 10 microhertz to 1 megahertz. So electrochemical setup is a 3 electrode system. It is working electrode, counter electrode and reference electrode. These electrodes are immersed in a suitable electrolyte. After immersing these 3 electrodes in a suitable electrolyte, then you can apply the potential or current, and you can measure the response. So even you can use the Faraday cage, it's only optional because it shields against electromagnetic interference. So computer with Nova software that controls the equipments and records and process the data. So working principle of PGStat 302N, you can control the potential of the working electrode, measuring the resulting current flow through the electrochemical reaction. So if it's a potentiostatic mode, then the potential is controlled. So the potential is fixed at a particular volt and current is measured. In galvanostatic mode, current is controlled and potential is measured. So in EIS mode, a small alternating current signal is superimposed to extract impedance data. The data are collected digitally and analyzed using Nova software for modeling and curve fitting. So Nova software interface, that is, Nova is the control and data acquisition software with the Autolab. The features of this Nova software interface is free-defined and customizable procedures for cyclic voltammetry or linear sweep voltammetry, PDP, EIS, etc. Real-time visualization, equivalent circuit modeling, powerful scripting tools for automation, exporting to CSV image formats and fitting models. Typical workflow: So they set up the experimental procedure, define potential or current ranges, run and monitor live data, and analyze and exports results. Coming to the impedance spectroscopic studies, the important plot obtained will be, that is Nyquist plot. It's a graphical representation of impedance data measured via electrochemical impedance spectroscopy. X-axis is a real impedance axis and Y is the negative or imaginary impedance values are plotted. So data is typically plotted as a semicircle or depressed semicircle. So the diameter of the semicircle, that is more or less directly related to charge transfer resistance. High frequency intercept, that gives the solution resistance, and low frequency dial diffusion effects or Warburg impedance. Nyquist plots are helpful for analyzing corrosion resistance and passive film properties. Nyquist plot, that is interpretation, perfect semicircle indicates ideal capacity behavior. The impedance plot, if it is a depressed semicircle, then due to surface heterogeneity or porous film. If you obtain two semicircles, then often due to two time constant and linear tile at 45 degree suggests diffusion limited process, that is Warburg behavior. Then fitting, curve fitting the Nyquist data with the equivalent circuit allows quantitative analysis of electrochemical impedance. Board plot interpretation. So in the board plot, in x-axis frequency is plotted and y-axis impedance magnitude. So high impedance at low frequency, that is equal to good corrosion resistance. So impedance value, if it is high at low frequency, then good corrosion resistance. Slope of -1 indicates capacitive behavior. Play 2 at low frequency indicates polarization resistance, used to assess barrier performance of coating or anodic films. In terms of board plot with phase angle, x-axis frequency and y-axis phase angle, and phase angle indicates a phase shift between the voltage and current, and this phase angle, if it is equal to -90, then it's a pure capacitor or ideal, the material have ideal passive behavior. If you get a multiple peaks, then multiple time constants in the given system. If it is a broader peak, more stable and uniform oxide film is formed. A high and broad phase angle at intermediate frequencies indicate a stable and a protective film. Low or shifting phase angles may indicate localized corrosion behavior or corrosion breakdown. So this is, for example, electrochemical impedance spectroscopic studies we did for our titanium sample. So the first one, Nyquist plot. So from the figure, the Nyquist plot, we got the board plot, real impedance and imaginary value, and then phase angle versus log frequency, and this is the equivalent circuit. So the table shows there is different parameters like solution resistance, then R1, R2 and Warburg impedance, etc. So coming to the potential dynamic polarization technique, that is a controlled sweep of electrode potential while recording the current purpose. So it reveals how a material behavior under anodic or cathodic conditions. It is measured in 3 electrode setup. Already I told you, that is working, counter and reference electrode. So here the board plot obtained by applying the potential between -250 millivolt to +250 millivolt. Then coming to the potential dynamic polarization studies. So with varying water content, the corrosion resistance of the material that varies. So the anodized samples, that is by varying the water content. So anodized specimen showed lower passivation current compared to the substrate. So anodized specimen showed a lower ICAR value compared to the substrate with increase in ICAR value among the specimens as the water content increases. So polarization curve, that is interpretation. Cathodic region, that is dominated by reduction reactions. Taffel region, that is linear, that is log I versus E. Passive region, formation of stable film at low current. So breakdown potential or pitting potential, there is sudden rise in current, then the film breaks, film failure occurs. So from the table, ECAR, so corrosion potential, ICAR is the corrosion current, and anodic Taffel plots, B, the beta A and beta C, then polarization resistance, that is RP. So this RP, that is inversely related to ICAR, whereas is anodic or Taffel slopes. By measuring the beta A and beta C, you can relate the corrosion kinetics. So coming to the applications of this electrochemical experiments, electrochemical impedance spectroscopy and potential dynamic polarization studies, both are used to determine the corrosion rate, passive film stability of the metal, and can be also used by the biomaterials, that is simulated body fluid testing of implants, batteries, sensors. So in total, it is a versatile instrument for both fundamental research and product validation in labs worldwide. Now we will see the demonstration of, before starting the experiment, the suitable electrolytes is prepared, and then the solution is stirred for a homogeneous, the preparation of homogeneous mixture. Then it is filled with the electrochemical cell. So the electrochemical cell consists of three electrode system: working electrode, reference electrode, and counter electrode. So these electrodes are connected to the electrochemical cell, and using the software you can fix the parameters. So the potential and current values are fixed using in the software. Then the cell is, or the equipment is started. Then the results are interpreted